students will derive one relation if that is L2 equals to this relation we want to derive. Now, what is the meaning of this? That in the last case we discussed about the length of a rod. Okay, the rod is at 0 degree centigrade. Then we measure the length of this rod and it's found to be L0. Then you supply heat and its length increases. So when the temperature is T degree centigrade, Lt is the length. If it is the case, then we came to the conclusion that the Lt is L0 alpha T. Delta T is a T here because T minus 0 is T. Here is basically delta T. This is T, so in place of delta T I have written T because if this is the case, this is the formula that we are going to use. Now instead of 0 degree centigrade, not necessarily the rod length at 0 degree centigrade is given. Suppose its length at any other temperature is given, then what you will do? If its length at any other temperature is given and you have to find the length at any other temperature, then what you will do? That means if the L1 is the length of the rod at temperature T1, L2 is the length of the rod at temperature T2. So L1 and L2 are corresponding lengths to the corresponding temperatures T1 degree centigrade and T2 degree centigrade. So here T1 is neither 0 nor T2 is 0. So if T1 and T2 are not zeros, then this equation cannot directly apply. Okay, fundamentally you cannot apply this law. So you have to derive another formula like this. How to derive that? So we'll do this here. That the basic idea I'll just give you here. The basic idea is what is given is T1 degree centigrade, the length is L1, and T2 degree centigrade, the length is L2. Okay, that means I supply heat to the rod whose length is L1 at T1 degree centigrade to length L2 at any other temperature T2 degree centigrade. Now what I have to do is I will introduce the concept that we have learned so far, this concept that its temperature is T1 degree centigrade, but I'll assume that its length is L0. Okay, its length is L0 at temperature 0 degree centigrade. So I'll assume that the length is L0 as usual, corresponding to temperature 0 degree centigrade, but it's not given. But I will assume that this is heated to this. From its original length L0 at 0 degree centigrade, it is heated to this. Similarly, from its original length, it is heated to this. Okay, this is the basic idea, that this is heated from 0 to T1 and from 0 to T2. Then it is same as it is heated from T1 to T2. So using this, we can find the length between this temperature change. So basically, this is suppose 1 and this is suppose 2. Though in actuality, this has changed from T1 degree centigrade to T2 degree centigrade. The temperature is actually changing from T1 degree centigrade to T2 degree centigrade. But we will assume that this T1 degree centigrade is the rod has achieved this temperature from 0. Similarly, this rod has achieved temperature T2 from 0. So these two basic equations we'll write first, and using those equations we'll derive the relation like this. That means, had the rod been heated to temperature of T1 degree centigrade from 0 and the rod being heated to a temperature T2 degree centigrade from its 0 degree centigrade, if it would have been the case, then what we would have written? So write those two equations, then you divide those two equations to get the relations. Okay, so that means one equation is L0 degree centigrade, L1 T1 degree centigrade. Okay. Another situation. So first we write the equation for this. This equation will be, and another situation is from the same 0 degree centigrade you hit to another length L2, temperature T2 degree centigrade. Had the rod been written like this, this is the situation number 1, this is situation number 2, then you would have got two equations. So first write the equation 1 for this type of change and equation 2 for this type of change. Then what will happen? The equation 1 that we'll get here is, we have the general equation LT equals to, LT means here is L1, is L0 into 1 plus alpha delta T. Delta T means T1, because here delta T means final temperature minus initial temperature. Initial temperature is 0 degree centigrade, final temperature T1 degree centigrade. Okay, so this will be the case. Second, if I write this equation, this will be L2 equals to L0 1 plus alpha T2 here. Okay, again delta T is final temperature minus 0, something minus 0 is that the same number. Now I want to establish the relation between L1 and L2, so I will divide these two equations. So what we'll do, suppose this is equation 1 and this equation 2. So what we'll do, divide equation 2 by equation 1. What I will get? This is I will get L2 over L1 equals to this equation divided by this equation, L0 1 plus alpha T2 divided by L0 1 plus alpha T1. So you can cancel these two, and this L2 can be written as L1, L2 can be written as L1 times this value. Okay, so L2 is L1 times this value, means 1 plus alpha T2 divided by 1 plus alpha T1. This is the case. Okay, we'll keep in mind that we have to show that L2 is L1 into 1 plus alpha T2 minus T1. Okay, this is what you have to show, but so far we have only got this. Okay, so now L2 is L1 1 plus alpha T2. Okay, this is 1 plus alpha T2. This 1 plus alpha T1 will become to the power minus 1, because this is in the denominator. When it goes to the numerator, it is minus 1. Okay, so then, as I have told you that the property of alpha is the material specific. It depends on material.
So this far we have done, and I told you that alpha depends on the material, and because it depends on the material, so it is independent of any other parameters. Only when the material changes, the alpha will change. Another thing you must know about alpha that we have discussed, that alpha is a very small number. It's a very small number, whose order is of the order of value is of the order of 10 raised to minus 5 or 10 raised to minus 6, around that. So 10 raised to minus 5, you can imagine, is a very small number. So we can write, or if you write the squares or the higher powers of alpha, or similarly higher powers of beta or gamma, because all these three are mostly in the same order of the order of 10 raised to minus 5 or 6. So the alpha square or alpha cube will be very small, that we can neglect, and we can make it 0. Okay, so first thing is that the alpha is a small number, so therefore alpha square is a very small number. It is small, so it is very small, and alpha q is very small. So these factors can be 0. If you make it 0, then it's obviously, if this is a binomial theorem you have to use, 1 plus x to the power n, something like that. And you must know that if you expand this term, 1 plus alpha t1 to the power minus 1, this is of the order, this is of the form 1 plus x to the power n. axis of the form 1, this type of binomial expansion. If you go for the binomial expansion, you will have n plus 1 number of terms, but then if this x is found to be small, okay, if x is found to be very, very small, then you can write this as simply 1 plus the power into this term, this number. That's all. Because the higher powers are 0, we will have x square terms, but x means this term, this square of this term, and alpha square will come and become 0. Okay, so for a binomial theorem for smaller index, if this x is very small, if x is small, then if x is very, very small, that means it's much less than 1, then you write x1 plus x to the power n. You don't have to expand, only you write 2 terms, that is sufficient. But then 2 terms, 1 is there already, so 1 plus x to the power n becomes n into x. Whether this number is a fraction or positive number or integer or something, it doesn't matter, this will be the formula. So therefore, because this alpha is this term, alpha t1 is less than 1, so we can write 1 plus x to the power n as 1 plus nx. N is this into x, so this will become negative, minus 1. That means minus 1 is to be multiplied with this, so it becomes negative. So you'll write like that using a binomial theorem for small index. You write this L2 as L1. This will remain same, this because power is 1, doesn't matter, 1 plus alpha t2, and this one will become 1 minus alpha t1. Okay, this minus 1 is already multiplied to the second term. This is the approximation that we made. Now this L2 equals to L1, okay, into this you have to multiply these two factors. Okay, so this will become 1, I have to multiply 1 with this, and then this with this, then what will get 1 minus alpha t1. Okay, I'm directly writing that this into this plus this into this means plus this into the whole thing, that means alpha t2 into 1, then alpha t2 into alpha t1. So I'm just writing directly alpha t2. Okay, this is alpha t2, and this minus plus is minus, so minus alpha square t1 t2. Okay, this is what we'll get, because this is, suppose this is a plus b, and this is a minus c, something else. So just open the bracket, multiply it. So that is called you write in terms of terms, different terms. So there are 4 terms you will have like this. Now this is L2, this is L1 into what about this? The higher alpha square part will be neglected. So we'll definitely neglect this alpha square. As I told you, the alpha square is 0. So we'll make this alpha square 0. So we'll make this 0. We neglect this term and we are left with 1, 2, 3 terms. So this will become 1. This plus term is here, so I'll write the third term first. Alpha t2 minus alpha t2. Okay. Next we'll write L2 equals to L1. 1 plus, from these 2 terms alpha can be taken common and it becomes alpha common, so t2 minus t1. Okay, now this is exactly the equation we needed. L2 is L1 bracket 1 plus alpha t2 minus t1. This is exactly the thing that we discussed here. L2 is L1 into 1 plus alpha t2 minus t1. So this way you will derive the equation. Now in the next video we will be discussing or deriving the whatever we have derived for the linear expansion. We will do the same thing for aerial expansion, that if the plate is heated from one area which is not exactly at 0 degree centigrade but at any other temperature, then from that different temperature or from the temperature other than 0, if you heat it to any other temperature, then how to write the formula for that. That means it will be identical to formula like this. Here it is L2, here it is L1, so in place of L you will replace by A, area. So this is A2 equals to A1 into 1 plus, in place of alpha you will have beta. So the formula you have to derive next in video is A2 equals to A1 square bracket 1 plus beta T2 minus T1. Okay, that will do. Okay, thank you.